Now these points are crucial and must be understood. The sea underneath the horizon cannot be removed by zoom or telescope so that we can see what is hidden behind it. This goes both ways, from the lighthouse to the ships and from the ships to the lighthouse. This can only be achieved by gaining height. This should immediately tell you that if the Earth is flat, then light is surely bending. This is clearly visible in this video promoting flat Earth. This guy is zoomed in all the way towards the horizon and he can see some buildings. Can he see the base of the buildings? No. Let's watch that again. He's zooming in. Can you see the Earth disappearing? Can you see the base of the buildings? Forget about them being slanted. Where's the base of the buildings? You just zoomed in all the way. Where is the base? It's gone. What, the mouse took it? The mouse ate it. What are you promoting here? This is the horizon. We're zooming in. And where is the base of the buildings? It's clearly missing. I don't see it. I don't see the sea moving away, disappearing. And I don't see any more of the building becoming visible. No, this is not proof of flat Earth. This is proof of an event taking place at the horizon. And that's either the Earth being convex, bulging out, cutting the light rays, or the light is bending, or both. It could be that the Earth is concave and that light is also bending in that case. This is not proof of flat Earth. Actually, it could be a flat Earth and light bending. But it's not straight light. Straight light cannot do this. This is impossible with straight light. Forget about straight light on a flat Earth. And number two, in the flat and convex and concave Earth models, the angle of elevation of the horizon is always negative. Even if it's small, it's always negative. You have to turn your camera, your view angle below the water level at your position. So it's always negative because you have to point your line of sight down in order to meet the water level. When you see something appearing anew on the edge of the horizon, and you know that the object is at a higher elevation than you, for example, the light from a lighthouse, which is 150 feet high, is taller than you. The 6th floor window of a tall building, you know, is taller than you. Then you should know that the angle of elevation to that object should normally be positive. Under normal circumstances, you would have to turn up in order to see that. But if that point appears at a negative elevation, that should immediately tell you that if the Earth is flat, then light is most certainly bending. Why? It means it appears at a lower elevation than you on a flat Earth. So when you're looking at this, when you're looking at this, I don't know, the 20th floor of a building, the 10th floor, the 6th floor, even the 1st floor of a building, you should be looking at it with a camera elevation in the positive. Did the person taking this video check the elevation angle of his camera? He can see the first, second, third floor windows of a building on the edge of the horizon, and the edge of the horizon, I'm telling you, its elevation is negative. He's pointing his camera down towards the earth to see the 10th floor window of a building. What does that tell you? It tells me very easily that if I'm on a flat earth, light is bending. There is no other way that you can get around this. If the earth is flat. So this is the law of bending, guys, on a flat earth. Yes, if the earth is flat, there is an obstruction and it's called light bending. If it's another shape, then it's another event is taking place here, which is the curvature of the earth or a combination of both.